Good morning, class. This should look familiar to you. This is called a coordinate plane. You should have graphed points last year when you were in 7th grade and probably before that too. So this is called the origin. That point right there we call the origin, and its coordinates are 0, 0. This is the x-axis and this is the y-axis. And when we graph points, let's say I want to graph a point 2, negative 3, the first number always refers to the x-coordinate and the second number always refers to the y-coordinate. So left and right are the x direction, up and down are the y direction. So if I wanted to graph the point 2, negative 3, I would go 2 in the x direction and negative 3 in the y direction. This point is 2, negative 3. Now this is all information you've learned before, but just a recap because of what we're about to do. We're about to graph different kinds of functions, and we're going to do that using a table. So let's grab this little piece of paper right here. We're going to talk about graphing this function. Now you don't know what functions are yet, but I want you to know how to graph things. You can graph any type of equation. Some equations are called functions. You can type any kind of equation using a table. So what we do is we find a bunch of coordinates and then we graph those coordinates to see what the function looks like. So when I look at a function that I'm going to graph, I look to see what kinds of things are happening. And when I see an absolute value, I know that absolute value, I get the same answer for a plus 2 as I do a negative 2, positive 2 and a negative 2. So I want to be careful and I want to make sure that I include both a negative and a positive of a same number so that I can see what's happening in the graph. What you choose is totally up to you. There's no set way that you have to do it. You could choose anything you wanted. However, the graph paper that we're going to use is a 10 by 10 grid. So I would never choose anything right now less than negative 10 for x or y, or more than 10 for x or y. So just keep that in mind. Now, in equations, not everything is going to fit on every equation isn't going to fit on a 10 by 10 grid, but for the ones I give you, they will. So let's get started. Let's say I choose a negative 2 for x. What that means is I come over here and I put a negative 2 in for x. So I say negative, the absolute value of negative 2 plus 4. Well, 2 plus 4 is 6. So when x is negative 2, y is 6. Negative 2, 6 is a point in this equation. It's a solution for this equation. Hear the bell? I know. You should be in school right now. Okay. Let's pick a positive 2 because we want to see what happens. Well, remember, an absolute value of a negative 2 is the same thing as the absolute value of a positive 2 because absolute value means how far am I away from 0, and 2 is the same distance from 0 as negative 2. So this is still going to get me a 2 plus 4, which would be 6. So now I have another set of points, 2, 6. Let's try 0. 0 is usually an easy number to pick. So I put a 0 in there and I get the absolute value of 0 plus 4. Well, 0 is 0 away from 0. The absolute value of 0, 0 plus 4 is 4. So when x is 0, y is 4. And I'll just try a few more. Let's try a 3. If I put a 3 in there, what do I get for y? X is 3, y is 7. So my point is 3, 7. If x is negative 5, get a negative 5 in for x, I get 5 plus 4, which is 9. I'm getting a little close to that 10, so I probably don't want to go any further down than negative 5 on my x's. Try something maybe larger, like maybe 4. If I put a 4 in, I get 4 plus 4 is 8. So when x was negative 5, y was 9. When x is 4, y is 8. So now I go to my graph paper and I'm going to graph this function on this paper. So the first point was negative 2, 6. That's negative 2 in the x direction, positive 6 in the y direction. 2, 6. 2 in the x direction, 6 in the y direction. 0, 4, 0 in the x direction, 4 in the y direction. 3, 7, so I go over 3 and up 7. I go over 5, let's see, 1, 2, 3, 4, 5, and up 9. I go over 4 and up 8. And then I connect the dots, and I see that these look like they're all in a line right here. Connect those, and this looks like it's kind of in a line too. But you'll see that it makes a V, and you'll notice that absolute value equations normally make a V. Okay, we're ready for our next one. So now we're going to graph this one, and how we're going to do that is by creating a table of points. So again, I like to look at my function, 2x minus 7. Okay, well, nothing happening with the x like an absolute value or something, so I'm pretty sure that I can just plug values in and I don't need to worry about like the positive and negative value, because a positive and negative isn't going to change this part right here to make it the same like the absolute value did. So I just randomly pick it. I like to pick 0 because it's easy. Because what's 0 times 2? 0, right? So that's 0 minus 7, so y is negative 7. So that means when x is 0, y is negative 7. So I'll pick like a 3. 2 times 3 is 6. 6 minus 7 is negative 1. So when x was 3, y was negative 1. So I pick like a negative 2. If I put a negative 2 in, what do I get? I get negative 4 minus 7. That's negative 11. Well, that's kind of beyond my, oops, I'm sorry, that was a negative 2. That's kind of beyond my graph. Remember I said the graph paper I have right here goes to negative 10. So I probably won't graph that point, and then I probably won't pick numbers less than negative 2 because I know that they're going to keep going down. So I'll go with another positive number, like maybe 5. I'll check 5 out. So 2 times 5 minus 10. What's 2 times 5? 10. What's 10 minus 10? 0. So when x was 5, y was 0. And I think I have enough points to graph it. Nothing weird going on, so come over here, get my little graph paper out. 0, negative 7. That's 0 in the x direction, negative 7 in the y direction. Then I have a 3, negative 1. Like I said, I'm not going to graph that negative 2, negative 11. It'll be down below. So I'm going to try the 1, 2, 3, 4, 5, 0. 1, 2, 3, 4, 5. Okay, something's wrong. Now I have to figure out what I did wrong. 3, negative 1, 1, 2, 3, 4, 5, 6, 7, 0, negative 7. Here's why I can tell it's wrong, because you might not know yet, but I know that that's supposed to make a line. And so something's wrong here. Let's see, I had a 3, negative 1. That looks correct. And this one, when I put a 5 in, 2 times 5 is 10. Oh, that's my problem. You guys probably found that a long time ago. That's supposed to be a minus 7, isn't it? So 10 minus 7 is supposed to be 3, not 0. Good job for those of you who caught it. If we were in class, yes, you would indeed get a lollipop. Okay, so that should have been 5, 1, 2, 3. Okay, so now see how it looks like it's in a line, so that's much better. I'm going to graph that. Okay, so now we're going to graph a different kind of equation. This year you're going to learn how to graph 3 different kinds of functions. And we've already done an absolute value function, we've done a linear function, and now we're going to do a quadratic function. How I can tell it's quadratic is that little x squared right there. Okay, so now let's remember what squared does. It times itself, so we're going to just pick some numbers. 0 I like to pick because, you know, it's pretty easy. What's 0 squared minus 4? Negative 4. So in this function, when x is 0, y is negative 4. And then I'll pick a 2, let's say. So 2 squared minus 4. Well, what is 2 squared? 4 minus 4 is 0. So when x was 2, I got a 0 for y. Now the thing about the squared is if you put a positive 2 or a negative 2 in, you really get the same thing. So I'm going to try a negative 2 and see what that does. Remember, when you put a negative 2 into something that you're squaring, you need to have those parentheses, because what it means is negative 2 times negative 2, which is 4. And when I subtract 4 from 4, I get 0. Okay, now I'm going to try a 3. So 3 squared minus 4, that's 9 minus 4, which gets me a 5. So when x was 3, y was 5. And I'll try negative 3 because of that squared property we want. We know that something squared, a negative squared, is also a positive. So here we get, again, 9 minus 4, which is 5. So whether we had a 3 or a negative 3, we still got a 5 for y. Well, let's see what that looks like if I graph it. Let's see if we have enough points to kind of get an idea of what that looks like. So I'm going to graph these points right here. So 0, negative 4 would be right there. 2, 0, and negative 2, 0. And then 3, 1, 2, 3, 4, 5 in the y direction. And it kind of looks almost like a V, but not quite, because if I went like that, I wouldn't hit that point. So I might want to go back and see what that 1 does. So I'll put a 1 in. What's 1 minus 4? Negative 3. So when x was 1, y was negative 3. Let's go back and graph that. And I can see that it's kind of curving a little bit more. Like that. This shape is called a parabola. It's kind of U-shaped. And that's what a graph looks like if you have an x squared as the biggest exponent in it. So now I'm going to give you some problems to do. So right now I'm going to pause the video and see if I can get you to do some.